Hi there. In this video, we're going to be talking about how to factor trinomials. Tri means 3. So these are polynomials with 1, 2, 3 terms. So how do we factor these? Well, what we're going to do is we're going to start, instead of diving into this problem, we'll take a look at this problem in a little bit. I'm going to work a problem in reverse, all right? And then we'll try to unwind that to see how we can get it back to get the answer, okay? So I'm going to look at, instead of factoring, I'm going to actually multiply two things together. So I'm going to take two generic expressions, ax plus b and cx plus d. So imagine that a, b, c, and d are all numbers. I'm going to multiply this out and see what we get. Why am I doing this? Well, because I know that factoring is the opposite of multiplying out. So all we have to do after we multiply it out is just run this process in the reverse, and we should have our answer. Okay, so if I'm going to multiply this out, well, one thing I could do is I could take this expression on the right, and I could distribute it across, because that's the distributive property for multiplication. So I'll have ax times cx plus d, and then I'll have plus b times cx plus d. Okay, now I'll do distribution again. I'll distribute this, and I'll distribute this. All right, so distributing, what do we get? We get a times c times x squared plus a dx plus bcx plus b times d. Okay? Now, let's realize that both of these have an x in them, so I can factor the x out. These are like terms. I can combine them in the following way. Okay, so what we have here is a trinomial. Notice it is of the form ax squared plus bx plus c. Okay, these are the types of polynomials that we are worrying about here. These are the things that we're dealing with. And we want to run this process in the reverse. We want to start with something that looks like this and get to something that looks like this, the factored form. So here's the not obvious at all observation I want you to make. If I take capital A and multiply it by capital C, let's just take a look at that. If I were to multiply these together, well, capital A stands for little a times little c. And capital C stands for little b times little d. So if I multiply these together, I could do that in any order because multiplication is commutative and associative. So I could write that as a times d times b times c, right? A times d times b times c. Now I wrote it in that order because these are exactly, this term and this term are exactly the terms I'm seeing here and here. And this is the very important observation. Now, like I said, it's not obvious that you would do that, but if you sat here and stared at it long enough, you'd probably think, well, let's see. I'd like to see where these things came from, so this is something to try, right? And you realize that if you multiply a and c together, yep, that's exactly these two terms. Now, what is this telling us? Well, this is telling us that whatever these numbers are in here, they are factors of a times c. And that is the key realization we need to make when we try to factor a trinomial, is we are going to take the product of a and c and look for factors of that product that add to b. And if we can find those numbers, then we can pull this apart and work this process backwards. Okay, so let's do that. So here's our problem, and we want to do exactly what we did. So what we did is we looked at a times c, right? So I'm going to take the product of 4 and 3. 4 times 3 is 12. Now remember, we're looking for two factors of that add to 13. So let's factor 12. Let's see, how does 12 factor? Well, 12 factors as 1 times 12, or you could do 2 times 6, or you could do 3 times 4. Those are 3 different ways to factor 12. Now I'm going to look at these factorizations, and I'm going to try to find the pair of numbers that add to 13. Well, it's the first one. Okay, if the problem is factorable, you will be able to find a pair that add to this middle number. Okay, so that's the one I'm going to use. So 12 factors as 1 times 12. Now, what did we do? Well, we noted before that if we pull this middle term out as the sum of those two factors, we will have an expression with 4 terms. All right, so let's do that. So I'm going to rewrite this top expression using these two numbers in place of 13. Right? So the 1 is there and the 12 is there. So I notice that these are the same, right? That should be pretty simple to verify that these are exactly the same, right? In fact, the numbers that I chose here were numbers that added to 13. So of course I can split up 13 in this way, right? But where are we now? Well, now we have not a trinomial, but a polynomial with 4 terms. Well, that is something we can try to use factoring by grouping on. Remember, factoring by grouping is exactly what we talked about in the last video. So if you need to refresh that, go back and watch that last video. But let's go ahead and apply factoring by grouping. Factoring by grouping says I'm going to look at the first 2 terms as a group. I'm going to factor out the GCF. So I recommend you pause the video, try to do this step on your own, and then unpause it and see if we get the same answer. Okay, we're going to do this factoring by grouping for the first 2 terms and the second 2. So do those and see if you get the same answer. Okay, so 3, 2, 1. Okay, hopefully you paused and figured it out. Welcome back. Let's compare what we got. So I'm seeing that the GCF here is x. And if I factor out an x, I'm left with 4x plus 1. And in the second 2 terms, the GCF is 3. And if I factor that out, I'm left with 4x plus 1. Whew! I'm really happy that these 2 terms here and here are the same. Because they're the same, I can factor that expression out. 4x plus 1 can be factored out. What do I multiply 4x plus 1 by to get this term? Well, just x. What do I multiply 4x plus 1 by to get this term? Well, just 3. And so there we have it. We have finished factoring our polynomial. All right, let's do another example. Now this one has a negative sign, so we're going to have to be a little bit careful here about the negatives, and we'll see where that comes up. But we're going to do this problem exactly the same way. We are going to first start by multiplying a times c. So if I multiply 3 times negative 15, I get negative 45. Now what I'm going to do is look for 2 factors of negative 45 that add to 4. So let's go over here on the side and factor negative 45. Well, it factors as 1 times negative 45. That's one factorization. Is 2 a factor? No. How about 3? Yep, 3 is a factor. 3 times negative 15. What about 4? No. What about 5? Yes. 5 times negative 9. And we could keep going. What about 6? No. 7? No. 8? No. 9. Okay. Yeah. So 9. 9 times negative 5. Now, you should notice that what just happened here is these 2 things are very similar, right? This is almost the same as this. I've just got the numbers flipped. And that's what's going to happen for the remaining ones, right? So once we get to a certain point, you're just going to start getting the same things you got, but you're going to flip them around. So the next one I can already tell is going to be 15 times negative 3. And then the next one is going to be 45 times negative 1. And I have them all now. Once you get to the point where you get the same thing and it flips, then you know you're halfway. And so you just write down the remaining ones with the negative and positive reversed. Otherwise, you're just writing down the same thing. And then you know you have all of them. So here's all my factorizations of negative 45. Now I'm going to look for the factorization where the factors add to positive 4. Well, let's see here. Oh, this one right here. Right? This is the one I need. So the idea here is to break this back up as 9 and negative 5. And that's how I'm going to rewrite the 4x. So I'm going to rewrite my first expression plus 9x minus 5x. Okay, so now I'm going to factor by grouping. So I'm going to look at the first two terms and pull out the GCF. And I'm going to look at the second two terms and pull out the GCF. So at this point, I'd like you to pause the video, do this step on your own, and then unpause it, and we'll check our work together. Okay, so 3, 2, 1. Okay, welcome back. Let's see if we got the same thing. So the first two terms here, my GCF I'm seeing is 3x, right? And when I factor that out, I get x plus 3. Hope you got the same thing. The next one, I know that I pull this minus down, and I see the GCF here is a negative 5. And when I factor that out, I get an x plus 3, noting that negative 5 times positive 3 gives me negative 15. So be careful with the signs here. And now I see that x plus 3 is a common factor, so I can factor it out. So I'm going to factor out the x plus 3 and ask myself, what do I multiply x plus 3 by to get this term? Well, the 3x. What do I multiply x plus 3 by to get this next term? Well, minus 5. And so here's my final factorization. All right, our last example for today. Let's take a look at this one. So again, the same technique. We're going to multiply a times c. 3 times 10 is 30. So I'm going to be looking at factors of 30 that add to negative 17. So let's go over here and factor 30. 30 factors as 1 times 30, or 2 times 15, or 3 times 10, or 5 times 6. All right? And I could keep going with this, 6 times 5, 10 times 3, 15 times 2, but I'm just rewriting the same things I already have, right? So no need to do that. So I'll just stop here. Now I'm looking for a pair of these numbers that add to negative 17. Uh-oh, none of these add to negative 17, right? They're all positive numbers, so they all add to positive numbers. So there's no way I can get negative 17 out of this. So am I doomed? Do I say this is not factorable? Well, wait a minute. There's other ways to factor negative 30, right? I used positive numbers. But if you multiply two negative numbers together, you also get positive 30. So that's the trick here. I should have realized that. When I knew that they were supposed to add to a negative number, I should have known that at least one of these has to be negative. But in fact, they both have to be negative if the product is positive. So I should be looking at negative factors. Okay, so now that I look at these, can I find a pair that adds to negative 17? Well, I absolutely can. It's right here. Negative 2 and negative 15. So that's how I'm going to split up my 30. I'm going to write it as negative 2 times negative 15. And that's how I'm going to break apart my original trinomial. There we go. And now we use factoring by grouping. So I'm going to group these two terms together and group these two terms together. So please pause the video, do this step on your own, and then we'll meet back and see if we got the same answer. So pause, 3, 2, 1. Okay, welcome back. Let's compare our work. For the first two terms, my GCF that I'm seeing here is x. Right? And then what's left over if I factor out x? 3x minus 2. Now here, I'm going to factor out a, let's see, what's the GCF? 5, negative 5 actually. And if I factor that out, what am I left with? 3x minus 2. Oh, now I'm very happy. These two guys right here happen to be the same. That's fantastic. That means I can factor that out. And what do I multiply this by to get this term? Well, x. What do I multiply this by to get this term? Well, a minus 5. And so there we have the final factorization.